going to have a look at how to do this titration calculation. We know it's a titration calculation because if we look at the question, we're given the word titration. And it says in a titration experiment, 25 cubic centimetres of a 0.5 mole per litre solution of sodium hydroxide was needed to neutralise 10 cubic centimetres of a sulphuric acid solution. Calculate the concentration in moles per litre of the sulphuric acid solution. So a titration calculation usually asks you to calculate the concentration, and it gives you a balanced equation, which we can see. Step 1 of this calculation is to pick out the information from the question, because it's very easy to put the numbers in the wrong place. We're only interested in the reactants, so I'm just going to forget about the products. We're only told in the question about the sulphuric acid and the sodium hydroxide. So let's go back to our question. Let's see what we're told. So we're told that we have 25 cubic centimetres, that's a volume, and 0.5 moles per litre, that's a concentration. We look at the units, and we're told that that is about sodium hydroxide. We look in our balanced equation. Here is our sodium hydroxide. I'm going to write down all the information we know about the sodium hydroxide from the question. So we know that the volume is 25 cubic centimetres. I'm going to change that into litres straight away. The reason I've changed it into litres is if we look back to the question, the concentration is 0.5 moles per litre. I want to make my units per litre. Sorry, if my units are per litre, I want my units of volume to be litres. That's everything to do with the sodium hydroxide. I'm going to read on from here. Okay, was needed to neutralise 10 cubic centimetres of sulphuric acid. So again, that's a volume. We look at the units. Sulphuric acid. Sulphuric acid in my balanced equation is here. We need to recognise that sulphuric acid is H2SO4. Calculate the concentration of the sulphuric acid solution. So let's put this information, let's pick this information out. So we are told that the volume of sulphuric acid is 10 cubic centimetres. So again, I'm going to put that into litres straight away. It's 0.01 litres. And we're asked to calculate the concentration. So I'm going to put C equals moles per litre, question mark moles per litre. So that's what we're trying to find out about. And the chemical we're told the most about is the sodium hydroxide. I'm also going to just separate. I'm going to make 2 columns because I don't want to get my numbers mixed up. Right, step 2. Step 2 is usually, well it is in this case, finding out the number of moles of whatever we can. Often in a chemical calculation, you want to find out the number of moles. Often, but not always, but often you do. And to do that, we use N equals C times V. Remember that triangle we did a while ago? N, C, V. So number of moles equals concentration times volume. Now, it is the sodium hydroxide that we're told V and C for, so we can now go N equals C times V. So that's 0.025 times 0.5. So that is 0.0125, methinks. Just check that using a calculator. 0.025 divided by 2, well, times 0.5. Yeah, that's right. That's the number of moles of sodium hydroxide we've got now. So the next step is to look at our balanced equation and to look at our mole ratio. So step 3 is all about using the balanced equation to find the mole ratio. So what do we mean by that? Well, if we look at the balanced equation, sodium hydroxide has got the number 2 in front of it, and the acid has not got a number in front of it, and that means 1. So what that tells me is that if I have 2 moles of sodium hydroxide, it will react with 1 mole of sulfuric acid. That's what that means. It's a 2-to-1 mole ratio. Now, you've worked out that we don't have 2 moles of sodium hydroxide. We actually have this many moles, 0.0125. That's what you've worked out. So I'm going to write that down here. And my mole ratio, because it's 2-to-1, I need to half my number of moles of sodium hydroxide, because obviously to go from 2 to 1, we have 2. So I'm going to half that number of moles. So I'm going to divide that by 2, and that is going to give me 0.00625 moles. So those arrows are just saying, right, if we've got 2 moles, that reacts with 1 mole. If we've got 0.0125 moles, then that reacts with 0.00625 moles. Okay, I've just divided that by 2. So you now know how many moles of how many moles of sulfuric acid we've got. Final step. Final step is to work out the concentration of the sulfuric acid. Concentration is N over V. If we look back to our little triangle in step 2, we can see that concentration is N over V. Let's look down this column. What have we got? Well, look, we've got a number of moles from the last step. Number of moles is that. If we look further up the column, we've got a volume. So the volume is 0.01 litres. So C is N over V. So it's 0.00625 divided by 0.1, which is 0.625 moles per litre. And that's our final answer. It looks like quite a lot, but it's worth 3 marks. If you get that final answer, you get all 3 marks. If you go wrong somewhere along the way, well, you can pick up marks. You would get a mark for correctly working out that part, the number of moles. You would get a mark for correctly using the mole ratio. And you would get a mark for working out C equals N over V.